Hi everyone, welcome to Duality Repair. This is the Rotel RB-1080 power amplifier. This is the silver edition, and I've worked on one other RB-1080 in the past. So if you don't happen to find the answers you're looking for in this video, maybe go back and look at my previous RB-1080 video. Now, this is another unit sent in by a viewer, and the owner sent along with the unit several boxes of fuses. So you know that means let's not turn this on until we open it up and fix something. There's a little bit of a backstory with this unit. The owner purchased this with an understanding that there was a buzz in the left channel. Well, when he plugged it in for the first time, he discovered that there was no output at all from the left channel. So he opened it up. He found that both fuses in the left channel looked pretty bad, so he replaced them, plugged it back in, heard a crackling, popping sound, and then again had absolutely no output from the left channel. So we opened it up again, discovered that both fuses he had just replaced had blown. So that's where we sit with this amp. Let's get it open and take a look around. All right, and we're inside the unit, and I'm really glad I got to work on another one of these. The inside is just as beautiful as the outside. The general layout is fairly intuitive. So we have the right amplifier module on the right, the left on the left. In the front center is the toroidal transformer, and in the back center we have the 4 filter caps. 2 on the right are for the right channel, 2 on the left are for the left channel. So of course we're going to start by looking at this left channel here. And to do a completely thorough inspection and of course to work on it and test it, it's going to be easiest to remove it from the unit. So I'll do that next. To remove it, the first thing you need to do is to make sure that all 4 filter caps here are completely discharged. After that, you can remove all of these tie wraps connecting all the wires together. Then you can remove all these ground wires here from this ground plane. You can remove the positive rail from this cap here, the negative rail from this cap here. There's a few other connectors here and there. There's one in the back here that's fairly easy to remove. There's at least one on the bottom, and I can't see if there's one or two more on the bottom as well. After that, there's 4, 6, maybe 8 screws mounting the heatsink here to the chassis. So you just remove those screws from the bottom of the chassis. And then after that, this entire module will just pull out and you can inspect and work on it. Here's the left amplifier module. I wanted to make a quick note on the removal because it is important. Before you attempt to remove this from the unit, you want to be sure to remove this screw here. This is mounting the balanced input to the back faceplate. If you don't remove that, you could potentially break this off of the board. Now, I've inspected this board for a little while now, and although most of the components look to be in really good physical condition, there's one that's definitely dead. That's this diode here, D603. D603 is sitting in the glue that's holding down the 3 caps here. And this glue can definitely become conductive and or corrosive over time, and I think that's what happened. Now, although the diode is bad, it's obviously completely open and it's bad, we need to make sure that we fix the rest of the problems on the board before we try and power it up. So I have verified that there is a short. If we look at the 2 fuse holders here, obviously the owner left the fuses removed before he sent it out to me. But we do have a short. So if we look at the positive rail here, that's the red wire. It's obviously leading to this fuse holder here. I don't have the fuse here, so I'll just jump straight to this end of the fuse holder. And if I put my other lead on the output, you can see we're completely shorted. So we're shorted from the positive rail to the output. The negative rail appears to be okay, which is good. But we do need to focus on the short between the positive rail and the output. So to inspect even further, I'm going to remove the board from the heatsink. So to do that, I just need to remove all of the screws mounting the output transistors to the heatsink. I need to either desolder this component here from the board or just cut out this thermal compound here. And then remove the 5 or 6 screws mounting the board to the heatsink. It should just come right off. All right, the board has been removed from the heatsink. And thankfully, there's nothing to note on the back. It's very clean. At the end of the last clip, I was measuring directly from the negative rail here to the output here, claiming that there's no short on the negative rail, but of course this doesn't prove anything because there's no fuse in the fuse holder here. So let me show you that indeed there is no short on the negative rail. There you go. I'm sure someone would have brought it up in the comments if I hadn't done that. Now you'll see I have 3 transistors removed already. If we look at the schematic, we can see that there's only 5 components in between the positive rail and the output, and that's these 5 transistors, Q637, 39, 41, 43, and 45. So I knew that one, several, or all of those had to be shorted. I started with 645, that one was fine. I moved on to 637, and that one was fine. Finally, I hit it in the middle here, 641, and that's this one right here. So if we measure this transistor, short, and short, and short, completely shorted across all 3 pins, so this one is gone. It'll obviously have to be replaced. This is a C3856 NPN transistor, fortunately still readily available from DigiKey and likely other suppliers, so it will not be a problem to replace. And now if we measure from our positive rail to the output, we can see that our short is gone. So that one lone transistor was causing our short and very likely causing our fuses to be blown. Now going forward, still have quite a bit of work to do. Although they're probably in really good shape, I'm going to remove and replace all 5 electrolytic capacitors just to make sure we make this board last as long as we possibly can. While they're out, I'm of course going to remove all of the glue. Again, there's only glue behind 3 caps, but I'm going to remove all of it. I'm also going to inspect and replace as necessary the few components that are partially sitting in the glue. So there's a diode right here underneath this cap. There's a resistor hiding as well between this transistor and this cap. And then most importantly and most concerning is a resistor sitting right next to this cap here, which is almost completely covered in the glue, and it's a very important resistor. It's the negative feedback resistor. So I'm definitely going to want to inspect that and replace as necessary. And of course, I'm going to remove and replace what's left of diode D603. So I'm going to get to work on all of that. All right, this board is ready to go. You can see I've removed all of the components that I discussed, as well as the glue. I also removed the rest of the positive rails output transistors because I was a little concerned. So I am going to test all of these before I reinstall, and I'll replace any that are questionable. So you can see I have the caps removed over here to the left. Again, these are probably in decent condition, but I'm just going to replace them with brand new anyway. I have the 4 components as well that were questionable. One of them obviously failed. That's the diode D603. That's completely open. These 2 resistors seem to be in good shape, but I'm going to replace them anyway because they do have glue on the leads. And then this diode was probably on its way out as well, just like 603. You can see that lead is starting to be eaten away, just like the other one was. So that definitely will need to be replaced as well. I'll get all of this done and come back when we're ready to reinstall. I plan on using my Atlas DCA 55 meter to test all of the output transistors. Now this isn't a completely thorough test. It's not a curve tracer. It's not going to tell you if your transistor is going to fail at high voltages, but it does give you a higher degree of confidence in the transistor over a plain multimeter measurement. I plan on using a new transistor here as a baseline and compare the measurements to all of the old transistors just to see if there's anything marginal with those. So I'll scroll through one measurement here with you. Of course, gives you the pinout, gives you the current gain, goes over the test conditions. So here's the collector current, gives you the base emitter voltage drop, more test conditions. This is the base current, and finishes with the leakage current. Here's the final product. I think it turned out really well. You can see behind the transistors I have some new pink thermal pads. I had to get rid of these old brittle fraying ones. They were pretty much useless. So now I will get this reinstalled and we're ready to test. The left amp module has been reinstalled. The unit's plugged in and I'm ready to power it on. Alright, the protection LED has been extinguished and I didn't hear any scary sounds coming from the left amp, so this is a very good start. Let me try and play some audio here. I can hear it very well through both speakers, so this is great. Before we go any further, I'm going to let this warm up for a few minutes and then we'll check the bias adjustment. Alright, the amp should be good and warm now, so we're ready to adjust the bias. I have my multimeter connected to test points 1 and 3 on the left amp module, which is on the far left side of the board there. You can see we're reading 5.6 millivolts and the spec is 7 millivolts. So I'm going to adjust VR601 here to get as close to 7 millivolts as I can. And it doesn't take much. I'm just barely turning that clockwise. And I'm good with that. We're going to hover around 6.9 to 7.0 millivolts. So let's turn this back around and do a final sound test. Time for the final sound test. I do wish I had a higher quality microphone so you could get a better understanding of how good this does sound, but I'll let you listen with what I have for a minute anyway. Just sounds really, really good. I'm very happy with this. Now I am also going to work on the right module as well. It has the same glue, it obviously has the same cap, so I'm going to remove the module, I'm going to remove and replace all of the electrolytics. I'm going to remove all of the glue as well. Luckily on this right side, the glue doesn't look to be touching any of the components, and if it is, I will replace those as well. But I'm not going to show that just because it's going to be pretty much a mirror image of what I did on the left side. Before I go though, I do want to go to the schematic just for a minute and we can discuss what might have happened to this amp. Alright, the last thing I wanted to do was to take one more look at the schematic, do a recap of what we found, and maybe talk a little bit about what might have actually happened to this unit. So we know that D603 went open because it sat in the corrosive glue. We know that Q641 shorted across all three pins, ultimately causing our fuses to blow. So if we look at D603 in the circuit, it's working in conjunction with D601, R621, D605, and D607 to form the bias circuitry for transistors Q611 and Q605. These two transistors provide the current source for both differential input pairs over here on the left. So it's my thought that by diode D603 going open, it would dramatically affect the performance of the differential input pairs, and this could potentially have caused the transistor Q641 to go short. But I'm not quite sure. If there's any of you out there who have some theories about how exactly this might have happened, please enlighten me and the rest of us in the comments. Other than that, this repair went really well. As I said before, I am going to recap and remove the glue on the right amp as well, and I'll of course verify the bias is good on that channel too. Other than that, this video is done, and I appreciate you watching. We'll see you next time.